See about the stick diagram. So on completion of this topic, students will be able to draw the stick diagram for the CMOS inverter, and also they can draw the stick diagram for NAND and NOR gate. So stick diagram in VLSI, here we are using to lay out the transistor of the cell. So this devices and the conductors we are representing in the form of the sticks or lines in the stick diagram. Here why it is essential means to define the direction and metallization of the power supply, that is ground, input and output, to create the circuit's architecture. So this stick diagram is a typical approach to symbolic design, and also this does not include any sizes of the transistors and wire lengths. And how does this designer draw a stick diagram means they creates a freehand layout design using colored lines to indicate various process layers such as diffusion, that is P or N metal, and polysilicon, where this polysilicon layer crosses the diffusion layer, and distribution of this poly connections are made by how this metal wires. So these design rules serves the connection of communication between the designer whose specific needs and the fabrication who materializes all those. So the goal of this one is to convert the circuit principles to silicon, and the stick diagrams may be used to represent the layer information using color coding. So for the depletion mode transistor, implanting inside the thin oxide can be required. So we need this design rules to draw the stick diagram, which is the interface between the designer and the process engineer. So some of the stick diagram rules are: when two or more sticks of the same type cross or touch each other, that represents the electrical contact, and when a polycross diffusion, it represents a transistor. In CMOS, a demarcation line is drawn to avoid touching of P diffusion with N diffusion, and all PMOS must lie on one side of the line, and all NMOS will have to be on the other side. Design rules allows transition of circuits into actual geometry in silicon, where it interfaces between the circuit designer and the fabrication designer. So why do we need the stick diagrams in VLSI means? These stick diagrams are a straightforward way of recording topography and layer information. So these stick diagrams use color codes to represent the layer information. Also it displays all the components, it dissipates the relative positioning of the components, it brings up one step closer to the layout, aids in the planing of the layout and the route. So here this polysilicon layer crosses the diffusion layer, and you can see here the polysilicon layer crosses the diffusion and the transistors are created. And design rules are the communication link between the designer specifying the requirements and the fabricator who materialize them. So first set of this design rules was introduced by lambda based, and mask design is aimed at turning a specification into mask for providing silicon to meet the specification. Stick diagrams may be used to convey the layer information through the use of color code. And for the depletion mode transistor, implant with the thin oxide is a must, and stick diagram and the mask layout is one and the same, but its mask layout aspect ratio and the distance between the dimension has to be shown. So here the encoding is green is represented for the stick encoding, that is it consists of the N diffusion plus the transistor channels, red polysilicon, blue metal, black contact, gray not applicable, and NMOS, that is yellow NMOS brown, it is buried contact. So you can see the different color codings here. This N channel type transistors and the PMOS and the PMOS channel enhancement. So finally this VDD, Vout, input, two inputs, and the output, that is ground. So substrate connection, demarcation line and PMOS connection is shown using this different types of the lines, that is color coded lines. So next we can see the function of the, that is stick diagrams for the example using F is equal to A plus B plus C the whole bar. So here how it is drawn means here we are also having some design rules that allows the translation of circuits into an actual geometry in silicon. So that is the interface between the circuit designer and the fabrication examiner. So here you can see two inputs, that is AND gate, and one input as OR gate. So this process wants design rules that should be controllable, reproducible process. Here we use lambda based design rules. So this design rules based on the single parameter lambda. If this design rules are obeyed, then mask will be produced working on the circuits. So all the path in all the layers will be mentioned in the lambda units, and also it is used to preserve the topological features on the step. So if you can see, the VDD is represented in the form of violet color, and the contacts you can see it in the black color, and this PMOS is shown in the form of yellow, and NMOS is shown in the form of green, and the inputs are shown in the form of the violet, and the contacts, metal contacts, are shown here in the form of black colors. So this prevents shorting, opens the contact from the slipping out on the area to be contacted. When there is no separation is specified, wires may can overlap or the cross, so that is this metal is not constrained by any other layer. So for PL CMOS, note that the N deficient wires can only exist inside, and P deficient wires will exist outside the P well. And main thing have to be noticed is this design rules. When contacts are made between the polysilicon and the deficient in the circuits, we have two approaches: buried contact and butting contact. Buried contact, no metal cap should be used to establish the contact. Butting contact, metabolization is used to contact this two things. So this, it is used to connect the higher level metals from the metal one connection. This design rule is minimum 2 cross 2, same as applicable through this inputs. So this like this way we have to draw for the NAND gate, NOR gate, and 3 input NAND gate and NOR gate. Quiz questions on the stick diagram. Draw the stick diagram for the given gate.